Okay, so today we're going to talk about choosing a good sample. So to choose a good sample, you want to have a good representation of the population. Like if I wanted to take a sample of something, like I wanted to measure something in the population, I want to get a good representation of it. Like I wouldn't just choose all random people. Like there's different methods of sampling. So to do this, you can create a sampling frame. A sampling frame is a list which identifies all members of the population. After that's created, you can proceed towards finding the right sample to represent your population. During this process, it is important to avoid selection bias, which occurs when the sample that has been selected overrepresents or underrepresents some segments of the population it's intended to represent. For example, Randall wanted to see if his community was going to pass an upcoming bond to rebuild his park. So he went to the public library at 10 a.m. on a Tuesday and surveyed the people he ran into. Why would this not be a good representation of the population? He went to the library, just one place. He just went on one day and at a certain time. Like, what's going on at Tuesday at 10 a.m.? Yeah, school, so you're not going to have any students. What else is going on? Work, so you're not going to have any kind of like business professionals. What kind of people are you going to see there? Old people, retired people, very, very young, like children whose moms stay at home. So it's not a very good representation of the actual public or the population that you're trying to identify. So keep that in mind when we're talking today. We're going to talk about different types of sampling. The first type of sampling that we're going to talk about is simple random sampling. Okay? That is when each member of the population has an equal chance of being selected. So there's a bunch of different ways you could do this. For example, you could assign each member a number, right? So in this class, I could assign each one of you a number. Then I could put those numbers into a hat and I could draw a number. Or I could use like a random number generator. Now, there are some flaws with this. Like, yes, it is simple, it is random, but like you might not get a representation that you're wanting to represent the population. Like you can't control some of those factors, but it does give each and every person an equal chance of being selected. Now, something that I do think is important to mention here is like random number generators and pseudo-random number generators. They're online. You just click a button and it's like boom, 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 and it like pops up a random number. Those actually technically aren't random. It uses a code. It follows a code, and like people can figure out those patterns with the code, so it could be like figured out in the future, but for all intents and purposes, it's really not that bad. Okay? The next type of sampling we're going to talk about is voluntary sampling. Now, voluntary sampling is when members of the population choose to respond to a survey. Okay? This is often used in media. So you have to be very careful with this. It is often used in media, and it typically provides biased results. Why do you think it typically provides biased results? Voluntary sampling. Yeah, only the people that are going to respond are the people that really want to be heard, right? So, only those who feel strongly about the matter will respond. So I want you to think about that. This is often used in media. You'll see it all the time. They'll be like, according to a recent survey, people really hate this. Well, if they post out a survey, only people who are watching and who are wanting to be heard about the situation are going to reach out. So for example, a bond right now. if they survey, if the local radio station surveys Hays, they're going to post it on their radio station and be like, go to our Facebook page and take this survey about how you feel about the bond. Only people who really feel strongly one way or another are going to go do that survey. They're like, no, I really don't want this. We can't have any more taxes. I'm going to go vote. Or yes, we really need this. I cannot live like this anymore. I'm going to go vote. The people in the middle, or the people who aren't listening to that station, are not going to be heard. Does that make sense? So be very, very careful with voluntary sampling. It is not always the best representation of the population. Okay, the next thing we're going to talk about is a census. Now, a census is when we survey each member of the entire population. Tell me, how often does the census happen in the United States? Every 10 years. When was the last census? 2020. 2020 was the last census. So a census is very, very accurate. It is very accurate, right? Because it's literally like reaching out to every member of the population, right? But there are some drawbacks to a census. Even though it's very accurate, it is incredibly time-consuming. Like, think about it. A lot of times we don't get the results of a census for years. It takes so much time to, like, get all that data together and organize it. It's also very expensive. Like, I think it costs like $97 per person for a census. Like, it is very, very expensive. And it's not always possible. Like, think about it. If we wanted to do a census of the entire globe, is that going to be possible? No. There's that colony in, like, what, South Africa, South Asia, whatever, that, like, nobody goes to because they will kill you on site. We can't take a census of those people. So it's not always possible. But the census can provide us with incredibly accurate information. So check this out. I have this website here. It's census.gov, so it's the government's census site, and it's the population clock. So I can go to this population clock, and it, like, has all of this information. It's so accurate. So right now, if we go to the United States, the U.S. population, is currently 332,577,124. And look, you can see, like, how it's changing. And then it also has the world population over here. But what's awesome is if you scroll down, it tells you, like, there's one birth every 9 seconds, and it has, like, a meter here. So this goes 9 seconds. So when it hits the end, someone's born, and then it starts over. When it hits the end, another person is born, and that keeps track with this. There's also one death every 10 seconds. So we subtract one from the population every 10 seconds. There's one international migrant. Now notice that's net every 130 seconds, all right? And then there's a net gain of one person every 45 seconds. So all of this taken into account, the U.S. is gaining one person every 45 seconds. Okay? Now, they also have interesting things like the top 10 most populous countries as of July 2021. Notice China's number 1, the United States is down here at number 3. And then it tells you, like, if you want a date, we could go back to, like, whenever they started the census. It can tell you whatever date, how many people were in the United States. It also can measure by growth by region, and this is really cool. United States population by age and sex. This is really neat. So here, 80, like if we talk about just, oh, I don't want that, just 80-year-olds, if I go to 80-year-olds, 0.2% of our population is 80-year-old men, and 0.25% of our population is 80-year-old women. Like, I'm 29, so if I come here, 29, 0.72% of our population are 29-year-old females. Mr. Getz is 30, so 0.71% of the population is 30-year-old males. But if I look at you guys are 17 and 18. 0.64% of the population is 17-year-old males, and 0.62 is 17-year-old females. And then we have 0.66 and 0.63 are 18-year-olds. It's pretty cool. That's my favorite part. Now, we can also look at most populous and highest density. Now, you're not going to find Kansas on any of these because, like, Kansas is not one of the most populous states at all. And then highest density is going to be a little different. So, like, highest density is, like, how many people they fit into a very small area. So District of Columbia, which is Washington, D.C., they have a lot of people in a very, very small area. So they are going to have the highest density, followed by New Jersey, because New Jersey is like around that New York City area, so very, very high density. Now, it gives you a little bit of information there, but that's just one of my favorite websites. So I did put that on the practice if you guys are like interested on looking through more of that, because like there are some more tabs that you can, you know, just, I don't know, bop around. I think it's exciting, sorry. Okay, so census, incredibly accurate, but it's also time-consuming, expensive, and not always possible. The next one we're going to talk about is systematic sampling. Okay, systematic sampling is very interesting. That's when you choose a starting point and include every case member of the population. I say K because like it depends. So let's say we have some people here. Okay, so I've got 1, 2, 3, let's draw our little stick people here, 4, 5, 6, 7, 8, 9. So I've got 9 people here, right? Systematic sampling is when I would look at these people and be like, all right, I want every third person to be in my population. So what I would do is I would say 1, 2, 3, this person's in. 1, 2, 3, this person's in. 1, 2, 3, this person's in. That's kind of like something you would see on sports teams when you're like breaking up for scrimmage. Coach is going to line you up and he's going to say, okay, your red team, your blue team, your green team, your red team, your blue team, your green team. It's like systematic sampling, so every like case member. So you could do that like in this classroom and be like, all right, I'm going to number you off. All the 2s are going to be in a group. Does that make sense? Okay. The next one we're going to talk about is stratified sampling. Okay. Stratified sampling is a little different. That's when we divide the population into strata, otherwise known as subpopulations, and then select some members from each strata. So a really good example of this is in our Senate. We have Democrats and Republicans. If we're creating a committee, we want a good representation from each strata. So we're going to make sure we get so many from the Democrats and so many from the Republicans. Okay, so that's like saying, all right, I'm not just going to say, here's all my senators, I'm just going to pick at random here. That might not give you good results because you might get all Republicans or you might get all Democrats. We want a good representation of both. So dividing it into strata can help you get a better representation. Now, strata can be any identifiable characteristic. But strata can be any identifiable characteristic that can be used to classify the population. So strata can be any identifiable characteristic that can be used to classify the population. So let's say the population that we're talking about is people, okay? So if we are talking about people here, strata could be sex, it could be income, it could be political party, like this example that we have here. What else could it be? Race, that's a really good one. Religion, that's an awesome one. And another one is location. Like, a location is a really good strata because, like, think about it. If we were to base everything off of, like, just people, the Midwest would not be very well represented because there's not many people in this location. So if we were to base it off of strata and say we need so many people from this location, and this location, that's going to give us a better representation of the whole country. So stratified sampling really is important when you have a large group you're looking at and you want to make sure everyone is well represented. Okay? Now the next one is called cluster sampling. Okay? Now, cluster sampling and stratified sampling can sometimes get confused. Okay? Stratified sampling is when you divide the population into strata and then select some members from each strata. But cluster sampling is when you divide the population into clusters and then select the entire random cluster. So here's a good example. Let's say I wanted to take a poll of the high school, all right? Now, the population would be the entire high school, but like to do it easily, I would do cluster sampling. So let's just talk about the hour for M2, okay? Now, I would divide the population into clusters. So like M2 would be Mrs. Getz's stats class, Mr. Brooks's psych class, maybe there's an environmental science class with Dickerson. I don't know if these are real classes. I'm just kind of making them up. There's a Spanish class with Haynes. And then maybe there's like an English 2 class going on with KWAG. Okay? So like that would be like a natural cluster that's happening. Right now we would be considered a cluster. Okay? However, the main difference between cluster sampling and stratified sampling is that I would choose Mr. Brooks's entire psych class and KWAG's entire English 2 class, and I would survey all the students. Okay? So I would survey literally all the students. So let's say Mr. H wanted to talk to you guys about the changes they made in the parking lot. And so he's like, all right, I'm just going to go into different classes during M2. So he would walk through the door and ask you all, be like, what are our thoughts on the new parking lot updates? Okay? And then he would go to Mr. Brooks's class and ask them all, what do you feel about the parking lot updates? Okay? So some pros and cons to that. It's easy to do, right? Like it's really easy to walk in and choose all of these people in this room. But is it always a good representation of our student body? No, because who's in this class? Only seniors, okay? So that might not be a good representation of the whole school. Or let's say he goes to a female weight class, there's no men in there. So like that doesn't get a good representation of everything. So yes, it can be easy, and depending on the things that you're surveying, like it could be helpful. For example, if he came in here and was like, hey guys, what did you think about that book that you read in English today? That would make no sense because none of you are in English class right now. Or if he went to Mrs. Wagner's class and was like, all right, we're going to talk about state assessments for math. Well, first of all, that's math, and second of all, that's only sophomores. Like, that doesn't help. Does that make sense? So it really does depend on what you're trying to survey. All right, now the last method that we're going to talk about is called convenience sampling. And convenience sampling is exactly what it sounds like. It's choosing members of the population that are convenient for you to access. Okay? Now, this convenience sampling is incredibly biased. Okay, it's incredibly biased. All right? It is not a good representation, even though it's so easy. And it's really just those that are close to your proximity. Okay, so like a good example of this would be like, all right, Tyler wants to survey about the new bond, so he's going to go stand on the corner by Hayes High and ask people who walk by him what they think about it. That's not a very good one because he's going to get mainly high school students that are walking, which isn't very many, and of course they want the bond to pass because they have to sit in these classrooms all day. Does that make sense? Okay, so convenience sampling is not a good representation. Another method of this would be like, all right, Marissa wants to know how people really like the cafeteria, like how they're liking the lunches. So she decides in the morning to go stand in the commons area and ask students about it. That's not a terrible idea because she's going to get the people who are experienced the most and she's going to be in that area. but an even better idea was to maybe do it at lunchtime so kids are like experiencing that. So like there are times when it's appropriate. You just got to make sure that you put the information where it goes. All right? All right. So given the following examples, we are going to identify which method of sampling that they are using. So again, we have simple random samples, voluntary sampling, census, systematic sampling, stratified sampling, cluster sampling, and convenience sampling. So number one, we are going to test each member of the entire sampling frame. What would that be? That's a census. When you do every single member, that's a census. Okay, number two, a student interviews the last 50 students to leave class. Convenience. They're just going to stand at the door and let the students pass them. Convenience. Okay. Number three, city managers wants to find out the public's opinion of a newly constructed road. They use a local TV station to encourage citizens to make a call to their hotline and share their experience. Voluntary, very good. Number four, a statistics student selects 15 classmates using a random number generator to select their student ID numbers. Simple random, very good. The reason that one is not stratified or cluster, it's not stratified because like they're not saying they have to be in stats, they just said classmates, so it could be like the entire school. And it's not cluster because they're not using the entire class. Number five, a random number generator is used to select 25 regions. Then a political strategist collects data from each person in these regions. Very good. Sorry, that would be cluster because they split it up into regions and then they selected the entire region. That's cluster. Number six, a market researcher interviews every 5th member from the entire population. Systematic. And then number seven, first the population is subdivided by class. Then a college student uses a random number generator to select 10 members from each class to study. Stratified.